The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to SMRP's webinar. Today, our webinar is titled Reliability, Essential for a Safe, Cost-Effective Operation, Part 2 by Ron Moore. So before we start, I'd like to quickly go through some housekeeping items. This webinar will be recorded and uploaded to the SMRP website within 24 business hours for you to download. If you have any questions throughout the webinar, feel free to ask them through the Q&A section. We'll answer them throughout the presentation. We will also have some time at the end for remaining questions. So let me introduce our speaker for today. Ron Moore is the managing partner of the RM Group and provides operation excellence seminars, culture change management and consulting, and benchmarking services. Ron is the author of Making Common Sense Common Practice, along with several other books and journal articles. He travels worldwide, working with industrial and manufacturing operations, and helps achieve operational excellence. And with that, Ron, I'll let you take it from here.
Alrighty, thank you, and thanks to everybody for coming back. Some of you are welcome if you're new. What I want to do before we get into this particular session is just do a real quick review of what we covered the last time. If you recall, last time we looked at the relationship between reliability and safety, and I shared with you a bunch of data. For example, here's a chart of correlating OEE, overall equipment effectiveness, with injury rate. And of course, and I've got 6 or 7 of these. So of course, as you can see, when the plant's running well, you have fewer injuries. We also looked at some data, other data. This is data from the University of Tennessee. And as you can see, as the reactive maintenance levels increase, injury rate increases. And some more data from the University of Tennessee. As reactive maintenance increases, maintenance costs increase. Well, surprise, surprise. And we also looked at this data. This is from a large US manufacturer, where we compared production costs, dollars per unit, to a thing called a reliability index. And as you can see, the better your reliability, which by the way includes design, operations, and maintenance, the better your reliability, the lower your production costs, not just your maintenance costs. And then we talked a little bit about the difference between the so-called reliability pyramid and the process safety pyramid from Leday and the second one from Hopkins, and pointed out that process errors create defects, defects induce process errors. Either way, you have a big boom or big problem. And so we suggested maybe, and I hope you guys can take this and run with it, that you want to revise your safety policy statement to include reliability. And so I offered you a format or a pro forma for doing that, and I hope you can do that. Then we did an introduction to what I call the reliability process, where we look at design, buy, store, install, startup, operate, and maintain. And we noted that most of the defects come from design, installation, startup, and operation. And therefore, maintenance doesn't really control reliability. They support reliability. So, and with that, we're going to get into a little bit of detail on each one of these. And we've got a lot to cover, so fasten your seatbelts. We're going to go through this at warp speed and try to leave a little time at the end to answer questions you may have. So, by the way, in the book Making Common Sense Common Practice, there's a chapter on each one of these if you're really interested in all the detail. So, design for reliability, operability, availability, maintainability. It's not just budget and schedule. And of course, you have to include a process hazards analysis as necessary. At one point in my career, I was VP of projects, and I focused on budget and schedule, and I didn't much care what happened downstream. And frankly, that was a mistake. I hope you can apply some life cycle cost principles in your efforts around capital projects. I've got some data, though, that suggests Well, let's look at this chart first. You got cash flow on the vertical axis. You got time on the horizontal axis. Okay. What I found is you'd probably be better off to spend a little more money and take a little longer time, notionally an extra 10%, and you get that money back in the first year of operation because you eliminate and minimize the risk of a bunch of problems that most of us have experienced in the startup of a major capital project. So, and like I said, I've got data around this. You might want to think about that. Let's talk about purchasing. Purchasing focus here is on total cost of ownership. Well, that's kind of like life cycle cost, just restated. So what is total cost of ownership? Well, here's a model. Total cost of ownership includes, well, as you know, things like price, drawing, selection effort, procurement, transaction costs, and delivery, and all that sort of thing. You know, most folks can, you know, do this, calculate this, determine this really pretty well, you know, fairly accurately. Where they sometimes fall over is when they're trying to determine the potential performance capability, maintenance requirements, part stocking, service levels, all that sort of thing, the things that are a little more nebulous when you're buying things. And those really need more attention. And so where do you get that information? Well, you go talk to the folks operating and maintaining the plant to find out what works well and what doesn't. And you factor that into your capital projects and your procurement process. Here's a little factoid for you. Only about 25% of the total cost of ownership is in the price, and the rest of it is in these other elements. And so it's really important that we take a more holistic or systems level view in our capital projects and our purchasing practices. Let's talk about stores for a minute. Stores are an asset, should be treated so, should run your storeroom like a store, like a business. So what does that mean? Well, have you ever been in a store that was nasty and dirty and didn't have what you wanted? Wasn't much of a store. So you're going to run it like a business, clean, efficient, good cash management, minimal stock outs, good stock levels, and so on. So you're going to hear really what you're trying to balance is the capital you've tied up against the service level. And I would hold both the stores manager and the maintenance manager responsible for both those elements, for the inventory levels, inventory turns, and the service levels or the stock out rate, because those are kind of in tension quite a bit. You know, you can have a spare plant. Well, not really. But ideally, that's what the maintenance manager would want. And then the purchasing and stores manager, they want no stock because that's working capital tied up. And you have to balance those two. So I would hold both parties responsible for both measures to get the balance right. So what about this so-called domains? When you're highly reactive, you need lots of spares. You don't know what you're going to need next. In the preventive predictive mode, you anticipate, you plan and schedule, fewer are required. The proactive mode, defect elimination, stop the failures and you won't need as many spares. And when you do, you'll know what you need and you can plan and schedule for that. And to have staffing consistent with the business needs, maybe a night shift to do kitting of parts so you don't chase parts all day if you're working maintenance. Do receipt inspection, stocking, cycle counts. You know, you want to run it like a business. Install and startup. Let's look at some data on this. So I'll let you read this, just give you a minute to read all this information, and I've got a couple of comments. So there's the data. So what does that say? Well, that says the risk of defects and problems and failures is really high during startup. So what does that say you need to do relative to your installation fabrication, startup, commissioning process. Well, to me, that says you better make that really, really good. Disciplined, intensive, structured, tenacious. Pick the words you like. Couple of comments though. Companies without apprenticeship programs have 5 times the installation startup defects. Wow. So why is that, I wonder? Well, I didn't do the study, but I suspect that if you don't have an apprenticeship program, your new guys learn through tribal knowledge, and tribal knowledge tends to be inconsistent and sometimes incorrect. And it's not very structured or disciplined. And when you have an apprenticeship program, it has to be more structured and disciplined. So those of you who abandoned your apprenticeship programs made a mistake. So I encourage you to sustain and maintain a good, solid apprenticeship program. Operate reliably. Let's look at that for a minute. Here's a quote from Charlie Bailey. He said, reliability cannot be driven by the maintenance organization. It must be driven by the operating units and led from the top. Now, this isn't a theory kind of statement, where you think something but you don't have data. Charlie tried to get better reliability by doing better maintenance, and so he bought predictive maintenance tools and got technicians in place and bought Maximo and got planners in place and so on. And he got a little bit of improvement. And that's a good thing, but it wasn't nearly what he was expecting or hoping for. So he went to the operating guys, production managers, and said, from now on, I'm going to hold you responsible for reliability. And of course, that creates a bit of tension, I reckon. And I'm going to hold you responsible for reliability, but I'm not taking it away from maintenance. And so I'm going to hold production guys responsible for things like maintenance and repair costs, because they're inducing defects that create repairs. And I'm going to hold the maintenance guys responsible for production schedule compliance. So when they want to do maintenance and it affects production schedule, they'll have to think twice. And I'm going to hold operations responsible for maintenance schedule compliance. So you share 2 or 3 measures that tend to be in tension with one another, and you get folks working together as a team to address the problems and the defects and to get to the root cause of issues. And when you do that, you get a remarkable improvement. You got about a 10% improvement in output, and among other things, about a 40% reduction in maintenance costs. So that's a history behind that quote. Another way of thinking about that, to expect maintenance to own reliability is like expecting the mechanic at the garage to own the reliability of our cars. Well, that sounds kind of foolish to me. Who owns the reliability of your car? Of course you do, just like I do. My car is a 1988 Jeep Cherokee with over 300,000 miles. Same engine, same drivetrain, all that sort of thing. I own the reliability of that old Jeep, so I make sure it gets looked after, taken care of. So what is this ownership thing? Well, tender love and care, condition monitoring, basic care in the operation. Ownership must have specific meaning, that is standards, practices, checklists, and so on, that operators help develop. If you want ownership, you can't just demand it. You have to engage the folks doing the work in helping you improve the work practices so that they have some sense of control, purpose, all that sort of thing. So now here's some data. This is, based on my experience and some other folks. Only about 10% of production losses are typically maintenance controlled. So if you look at the OEE measure and you take the losses from ideal, let's say that's 30%. What I found is that typically something on the order of 2/3 of that, or 20% of your 30%, has nothing to do with the equipment. It's things like product and process changeovers, rate and quality losses during transitions, raw material problems, market demand issues, all that sort of short stops. in a discrete plant? Well, about a third is equipment related, but when you go to root cause and you try to figure out, well, what caused those production losses, what you typically find is that about 2/3 of that 1/3 is because of poor operating practices. You didn't start it up right, didn't shut it down right, you ran it outside its inherent capability, and all that sort of thing. Which really means that maintenance only controls about 10% of your production losses. So your process reliability, if you want to think of it that way, maintenance only controls about 10% of that. So it's really, really important that you have a strong production-led process for reliability and to drive operational excellence. Here's some more data. A bunch of folks out there, different companies or institutes, looked at different failure modes and causes of failures, and they concluded that 70% of failures are preventable by operators. 2/3 of tasks to prevent failures were done by operators. This is Charlie Bailey's company. They looked at a bunch of failure modes, concluded 2/3 of those failures could be prevented by operators. So it's really important that we have that kind of relationship. Now, here's a chart, a graphic put together by Winston LeDay, ex-DuPonter, led the manufacturing game. He talks about different performance levels, or different domains rather, for certain performance levels. Regressive, well, you're going out of business. The reactive domain, you can go from a reactive domain to a planned domain by being maintenance led, and you'll get some improvement in performance. In fact, Charlie Bailey did that. Unfortunately, the planned domain is the least stable. Why is that? Well, maintenance leads it, maintenance owns it. And so that when you have this conflict between maintenance and production about how you manage the process, well, after a while, if enough of your maintenance gets postponed or delayed or whatever, it loses its credibility and people revert to reactive. Your best domain, and Charlie Bailey found this too, is proactive. It's production-led, using cross-functional teams to eliminate the defects and to manage the processes. When you have that cross-functional collaborative relationship, you get better performance. And then there's a strategic domain. I haven't seen that anywhere yet. Maybe it's out there. I just haven't experienced it. It's aspirational, if you will, organizational learning, all that sort of thing. So how do we address all these issues? Well, I believe strongly you got to have a good production and maintenance partnership, one that's production-led. Consistency of operation across the shifts. Run the process steadily across every shift. Too often, each shift wants to tweak things. That induces more instability. You need a good process conformance and capability. You need to have process conformance control measures that keep you within those upper and lower control limits. You need good shift handovers. Each shift works to make the next shift successful. And of course, you need operator care. Operators looking after and loving that equipment like it's their own. And here's some data on that. This is from University of Tennessee, Klaus Blake. Here's maintenance costs on the vertical axis and the level of operator care on the horizontal axis. Level 1 is none. And by the way, this is the average of each quadrant of the 4 quadrants. Level 2 is some. Level 3 is regular PM checks, and level 4 is regular PM checks and some repairs. That is, they're actually laying hands on the equipment, much akin to what a maintenance helper might do. We're not expecting operators to be millwrights or mechanics or anything like that. But what we are expecting them to do is to take care of the equipment, to look after it. So there's the data. Which one of those would you rather have? Well, that's pretty obvious, I think. So last comment here is a quote from my mother. Take care of the place where you make your living, so it will take care of you. You know, I've never understood how people can go to work and not look after the place where they work. You know, that job that you have makes it possible for you to make your mortgage payments, to feed your kids, to make your car payments, to have a vacation. Why wouldn't you take care of it? You know, folks that don't do that, I just don't understand it. And I would encourage you to take my mother's philosophy and, you know, spread it around a little bit. Okay, let's talk about maintenance finally. You know, and the reliability process is it's at the tail end of this dog. So maintain for reliability. Here's a model that I've used for years now. Maintenance strategy for reliability, integration of reactive maintenance, that is run to fail, emergency, breakdown. Let me give you my definition of reactive maintenance. It's work you did this week that you didn't plan to do last week, plus all those folks that you've held in reserve. You didn't put them in the schedule because you know you're going to have 10, 20, 30% reactive. So you didn't schedule them. So the sum of those two is your level of reactive maintenance. One other comment on this, I think you should schedule 100% of the available hours every week, but allow for breaks to the schedule. Two things will happen, and this is a Doc Palmer recommendation, and I'm a big fan of Doc Palmer. Two things will happen. One is you'll get more work done because people expect to do more work. Number two, you'll make more thoughtful decisions about what a break-in to your schedule is and should be. And because of that, you'll have fewer break-ins to your schedule and you'll get more work done. So moving on, preventive is time-based, once a week, once a month, once a year. You do something. You lubricate, calibrate, overhaul. Predictive is condition-based. That is, you got a comprehensive condition monitoring program where you detect problems early. You use that knowledge to plan and schedule and anticipate a requirement. You coordinate production and maintenance, and you do that work to minimize its consequence to the business. Proactive is root cause based. That is, and proactive is really more associated with changing the way you design, procure, store, operate, and of course maintain, so you eliminate the defects that created the requirement. Now this model says maintenance is a reliability function, not a repair function. And I know you have to do repairs. The point here being that when you do those repairs, you put reliability into the equipment by virtue of the precision and craftsmanship that you apply, by virtue of the skills that you've embedded in your workforce. But as we've seen, reliability is not just about maintenance. In fact, au contraire, I would suggest it's about getting all those processes right, the design, the procurement, the operations, and of course, the maintenance. Now, here's some data. This data is kind of dated, actually. We did this study back almost 30 years ago. Highly reactive, you know, a lot of operations out there. Now, this has improved over the past 10, 15 years, but there's still a high degree of reactive maintenance, a little time-based, a little condition-based, a little root cause-based. Let's compare that to the best plants that we saw, well, actually some 30 years ago and today. This data is still good today. Not much reactive, a little time-based, mostly condition-based, and a nice healthy dose of proactive root cause-based defect elimination activities. And all of this work is, you know, controlled, that is, it's planned and scheduled. This costs you about half as much as this. With this, you have lower cost. You're safer. You won't have as many injuries. You'll have better environmental performance. So now most folks these days are going to fall kind of right here in the middle, somewhere around 30%, give or take. You know, And I would encourage you to go back and have a look at how you're doing what you do and how well you're doing against this model. Now, one last comment, you will not achieve this level of performance without a production and maintenance partnership, one that is production-led. Well, some of you might think you can. Good luck. You know, I've never seen it. Maybe you'll be the first. But the point here is production and maintenance need to work together to achieve superior performance. And they need to have measures that they share to facilitate that collaboration, that teamwork. So let's move on. Now, here's a so-called classical failure profile used to justify intrusive preventive maintenance, time-based maintenance. So this graph here says your equipment has a certain operating life, and beyond that you go into a wear-out zone. Therefore, you do your PM, your replacement, your intrusive restoration, whatever, right there at that point in time. Well, that sort of makes sense except for one big problem, and that's this. Random failure is far more common. Something on the order of 80 to 90% of failures are random. And random failures are best addressed by doing condition monitoring. You know, if you did a time-based replacement on this equipment, you would actually do yourself a disservice. You'd have more downtime and more costs. So your best bet when you got a random failure pattern is to do condition monitoring, which includes, by the way, operators doing look, listen, feel, smell, processing, and equipment condition. So let's look at some more data. So here we've got on the vertical axis conditional probability of failure, and we've got different failure patterns. These percentages are the percentages of equipment in each of these studies that had this kind of pattern. So the bathtub curve, how often does that apply? Well, not very. How about the PM curve, doing time-based replacement? How often does that apply? Well, not very. Now, the U.S. Navy has a very different profile, and there are a couple of reasons for that. One is most of these failures here, if not all of them, are related to sea water corrosion. But the second reason is they've got exceptionally good consistency of practice in their operating and maintenance practices, high degree of consistency, which means you have less variation, which means you have greater consistency in the failure pattern when you have an age-related failure mode. So next set of data. Let's see, let's jump down here to the bottom, the infant mortality curve. 2/3, 2/3, 2/3. I'm skipping over the Navy because most of you don't operate like a submarine, excuse me, a submarine. But now one other point here, after about 30, 60 days after the infant mortality period, this probability of failure goes flat. In fact, it's flat here, and it's flat here and in between. What does that look like? Well, it's a random failure pattern. The probability of any one of these components failing is the same as the probability of any other component failing. How do you manage that? Condition monitoring. So it's really important that you have that. Let's jump ahead. So what are we trying to do with condition monitoring? Well, we're trying to understand the degradation process so that we can avoid or minimize the consequence of failure. So right here, the green dot, we have onset of failure. We don't detect it. Here we detect a potential failure at the yellow dot, but the system is still meeting all my requirements. So I might hear a wheat, but system's functional. Here, I'm not meeting all my requirements. And beyond that, I've got a functional failure until ultimately it's laying in a heap. This time period between the potential and the functional failure is called the PF interval. It's the time that you have to take some action to mitigate, minimize, avoid the risk of failure. Now, And there's some discussion I don't have time for about what happens when this window is fairly narrow. Back here, onset of failure, what are we going to do there? Well, we're going to work to stop or delay the onset of failure through defect elimination and process improvement. That way we have a longer life of the equipment and we can, minimize the risk of loss. So here's some data on all that. This is from John Schultz. Here's maintenance costs on the vertical axis. On the horizontal axis, we got percent of equipment on some sort of condition monitoring or predictive maintenance program, including operators. And as we can see here, the higher the percentage, the lower the cost. But now one other point here, you've got to have really good work management and planning and scheduling to feed this information into so that you can act on it. You can't just detect problems and then ignore them. You got to have the work management processes in place. And if you want to get way out here on the end of this graph, you got to have a proactive mindset for defect elimination. Stop the defects, you stop the failures, you have fewer, therefore you can manage those even better and you get a better outcome. Now from that same study, how about this one? Percent PM work, time-based work, that is beyond about 20-30%, your maintenance costs increase dramatically. Why is that? Well, I think it's two things. One is you're doing work unnecessarily. It's not, condition doesn't warrant it. And the second is you're restarting the infant mortality risk. So, and then if on top of that your work practices are pretty ordinary, then that only amplifies the risk and the cost. So don't assume your PM is correct. Here's some more work from John Schultz. He did a study of some 20,000 PM tasks. About 10% you could use as is. 10% delete, replace with condition monitoring, re-engineer, transfer to operations, transfer to a dedicated lubrication function. One comment I'd give you here is this. I think most operations, large, complex facilities, you ought to have a dedicated lube function. We talk about operators doing lubes. I think in most organizations, that's a bad idea. It works in an automotive plant where you got maybe 2 lube points and 1 lube. But think about it, you got 1,000 machines. You got whatever, 2, 3, 4, 500 operators. You got 4 different shifts. You got people with varying skills and abilities. You got 10 different lubes. What's the probability of error? Well, it's right near 100%. So having a dedicated lube function minimizes the risk of that. And here's some data from Roy Schuyler at DuPont. Mechanical availability is a function of maintenance cost. You have the highest availability for a given cost using this reliability focus. That is, it's the combination of reactive, time-based, condition-based, and last bit, that proactive element, the root cause defect elimination element. That's your best bet. So a little bit on work management and planning and scheduling, or planning then scheduling. They're different. Just a couple of comments. Your planning system will fail if the total number of defects overwhelm the system. I want to say that again because that's really important. Your planning system will fail if the total number of defects overwhelm the system. So the point being, it's really important that you have a process for eliminating, stopping the defects so you have less work so your planning system can be successful. And finally, I think you should have one plan. It's called a production plan. It includes the maintenance plan. Production and maintenance work collectively to a common purpose. They don't blame one another when things go south. And there's some more in there, some more stuff. I'll let you read that at your leisure. So how are we going to do all this? How are we going to support all this? Well, it has to be led from the top. Executive sponsorship is essential. and permission is not sponsorship or leadership. Active engagement is essential, much the same as it is for safety. And you got the data on safety at this point. You need a good production and maintenance partnership, some shared KPIs to facilitate collaboration, and a shop floor engagement process, structured improvement time, so that you put together cross-functional teams to address the issues and get them corrected. If you have all four of these elements, you will be successful. If you miss one or two or even four, it becomes less and less likely. So I suppose we want this really quickly, in the next year or two, we're going to do this. Well, your maintenance costs are probably going to go up 10 to 30%. Well, not likely. You're not likely to be able to get the money. Moreover, if I gave it to you, you probably couldn't use it effectively. So how do we manage that? We're going to break it into little bits, small bites, and keep chewing. Structured improvement time, small improvement teams, constantly going after all those defects. Now, here's some data from 180 manufacturing plants correlating OEE with certain practices. I already showed you this one. The more reactive you are, the poorer your practices and the poorer your OEE. How about this? All these other practices, the things we've just been talking about, the better those practices, the higher your OEE. But now notice no one of these is dominant. In fact, they all run around 30% or 0.3 correlation. So what does that mean as a practical matter? We must be tenacious about doing many things really well, working together to a common purpose, addressing all these issues. We've got to engage the entire workforce. Most of you have folks out there who have doing RCM or Six Sigma or RCA or whatever. You got some projects identified. That's a good thing. Keep doing that. But that only involves about 5% of your workforce. What about the other 95%? What are we going to do to engage all the workforce to stop all the little things happening? Because if you don't stop all these little things, they will converge and become big things. Here's some data from a study. Eliminating small day-to-day problems has a much bigger impact on results than focusing on the major failures. Now, to be clear, we're not saying ignore the major failures. That'd be stupid. Address them, but do the little things right. Engaged employees are 3 times more productive. And here's a comment I want to give you. If you want to understand the problems with the work, talk to the workers. 70% of all improvement ideas comes from them, according to Klaus Blake. And finally, nothing changes until the shop floor does things differently. So we got to get them engaged and involved. Another way of thinking about it is this little chart here. Now, according to Bob Kelleher, only about 30% of a typical workforce is engaged, 50% are disengaged, and 20% are actively disengaged. Now think about that. You got a rowboat, 10 guys on the rowboat, 3 of them are pulling on the oars hard. Boy, they're working, 5 of them are sightseeing. They're just doing the minimum to stay on the boat. And 2 of them are trying to sink your boat. It's really important that we engage all the workforce in helping us get better with that so-called structured improvement time. So let's look a little bit at leadership. Leadership, what is it? Well, it's the ability to inspire ordinary people to consistently perform at an extraordinary level. And I don't mean ordinary in any pejorative sense. I mean regular folks doing a superior job because you've put them into superior systems. You have the right training, the right tools, the right time, the right processes for them to succeed. And if you don't have that, they can't be. It's really up to management to create that environment. And it really begs the question, how do I get people to genuinely look forward to coming to work every day? I'll give them work they like to do, involve them in the improvement team, send them off to a training course, go talk to them, find out what the problems are, engage them, get your butt out there. Here's Peter Wickens' leadership model. He got processes on the vertical axis, people on the horizontal axis. The best quadrant here is what he calls ascendant. You've got rigorous processes and engaged people. How do you get that? You get the people to help you develop the processes so that they have a sense of ownership and purpose in them. Now, we've said that how many times? I don't know. Several. I hope it's starting to stick. Organizational alignment. Here's some data. Just read through this data. Give you a minute. I think that's awful. Well, to illustrate how awful it is, let's suppose it's not that bad. It's actually twice as good. It's still awful. Consider the consequences of this if you were a coach and your team's athletes felt this way. Wouldn't be much of a team. So why do we need to align the organization? Well, there's some studies been done. Edgar Schein wrote a book called Organizational Psychology, a really totally boring book. But the point he tries to make is that, people are naturally competitive. It's innate in our behavior. And what he says is alignment is critical where task interdependence makes collaboration essential for organizational effectiveness. Let's read that again. Alignment is critical where task interdependence makes collaboration essential for organizational effectiveness. So when you have all this task interdependence, for example, between production and maintenance and stores, marketing and manufacturing, and all that sort of thing, between shifts, you've got to have collaboration. And to facilitate and foster that collaboration, you got to create superordinate goals that take priority over group interests. Remind people to focus on the higher level goals. Think at a systems level. Don't optimize in your little silo. Think about the system. Develop shared measures between competing groups and partnership agreements to help facilitate that teamwork. A little bit on performance measures. Our measures must expose our weaknesses. OEE is a great measure for exposing your weaknesses. Must facilitate collaboration, not conflict across functional boundaries, particularly when you have high task interdependence, and have the right balance of leading and lagging indicators. I think most folks would be far better off if they had more leading indicators, the things that the shop floor does, process conformance for the operators, leaks, alarms, all that sort of thing. And for the maintenance guys, number of bearing failures, number of seal failures, all that sort of thing. Leading indicators, that is what the shop floor is doing, because if you get that right, the lagging indicators have to improve. Measures should matter, be used to drive behavior, but be careful about driving silo behavior. So have some collaborative measures. Be visible and current and maintain that way, and limited to our span of control and ability to manage. Having 25 measures, I think, is almost useless. Having 5 measures that you can manage is useful. About managing cultural change. Culture, that's what people do when the boss isn't around. And I know the technical or the proper definition of culture, but I like that one. So read this. Couple of points here. Most managers got to where they are by doing what they've always done. And we might be asking them to rethink that. And that's really difficult for them. Now, the second quote here from John Shook. You must act your way into a new way of thinking. That is, you must do things differently and repeatedly before it becomes a new habit. You can't just ponder. Of course, you do a little pondering before you act, I reckon. But you got to do things differently and repeatedly before it becomes a new habit. So here's a model for managing cultural change. You got to have a compelling reason for change. You got to communicate the strategy, goals, and roles repeatedly. Leaders want change, managers want stability. Well, you have to do both. It's a bit like a stair step. You challenge current performance, you stabilize that. And the heart of it, though, is this. You got to facilitate employee implementation of the change process. People own what they create. You have to make them part of the creative process in managing the changes. Measure the results, reinforce good behavior, challenge bad behavior, and then stabilize the change and the new order through procedures, standards, checklists, and the like. I want to touch a little bit further on this blue box here, facilitate employee implementation. People don't want to change. That's a question. About half of it you would say yes, and about half of you would say no. Well, here's what I think. I think people do want to change if given compelling reasons, if there's something in it for them, more secure future, better pay, less stress, and so on. And most importantly, if they participate in the design and the creation of the changes. That's why structured improvement time, training, and so on, asking them what they think is so important. All three ifs must be addressed. Stabilize the changes, procedures, standard checklists, and so on, and that's all good. But we've got to assure management stability. It's very difficult to have process stability with frequent management changes, and I see that's a huge issue in most organizations. If the change takes longer than executive or organizational attention span, it is doomed to failure. Constancy of purpose is essential. That's a quote from Deming. He was a strong believer in constancy of purpose, and so am I. So, reliability, it's essential for a safe, cost-effective, environmentally friendly operation. So here's a question for you. With all this in mind, what are you going to do to support a comprehensive approach to reliability in your organization? So I want to pause here for about a minute. I want you to write down something you're going to go do with all this, because I want you to leave this webinar with at least one thing you're going to go do. So I'm going to put a timer on, and I'm going to let you go write this down, what you're going to do. So we're going to have a pause here, and then we'll take questions after you write this down. At this point, you should be writing. And if you finish one, write down another one. All right, that's 1 minute. I hope you've got something written down that you're going to go do that will make all the time you've spent with me worth your while. So with that, I'm going to turn it back to Jess. And Jess, if you have a question, if anybody has a question, I'll be glad to entertain those. And if we don't have time to entertain questions, the last slide is my contact details. I'll be happy to take a phone call or an email from anybody. So turn it back to you, Jess.
Great. Thank you, Ron. All right. So again, if anyone has any questions, you can ask them in that Q&A section. So we do have a few that came in during your presentation. So one person asked, is performance-based contract an effective opinion when outsourcing maintenance services?
It kind of depends on what the performance measures are. You know, if you're driving folks to reduce maintenance costs, but you don't have some sort of defect elimination process and a process for collaboration with production, you know, they'll reduce the costs. You know, but you might not be very happy with that a couple of years from now, because they'll do less work, and that less work will induce more defects that you don't come across until some future circumstance. I've got a contractor best practice model that I encourage folks to use, and if whoever asked the question, just send me an email and reference the question about managing contractors. I'll send you the material. Okay.
Okay, so another question we have is, what are the pros and cons of in-house and outsource asset management?
Well, that's a really complex question. I don't know if I can answer in a minute, but I'll give it a shot. I think that you should outsource things like low skill, high frequency work, like custodial work, or high skill, low frequency stuff. You know, things like, for example, aligning a turbine generator, or maybe relative to your workforce, overhauling a compressor. So low skill, high frequency, and high skill, low frequency, I think you should outsource. You should also, I think, outsource things like, you know, when you have a major project or a turnaround, shutdown, you're going to have to, because you just don't have enough internal resources. I don't think you should outsource so-called core competency functions. Now, you have to decide what a core competency is. And, you know, for example, maybe you might think about outsourcing your marketing function. Well, to me, that's a core competency. I wouldn't outsource that. You might think about outsourcing your production function. Well, to me, that's also a core competency, unless you just need supplemental resource for a particular surge in demand to address that. And so likewise, I think maintenance is a core competency. And unless it fits one of those other criteria, I don't think you should outsource that. And back to the question about incentives, it depends on what incentives you set up. You can set those incentives up so that you actually hurt yourself, not help yourself. Anyways, and same comment to that person, I'd be happy to send them the, the material on contractor management. Next one.
All right. Let's see. We do have several more coming in. What is the best practice? I think this is practice/percentage of maintenance tasks that should be condition-based.
Well, I think something on the order of half your maintenance costs or labor should be condition-based. Okay. Now, some of that is going to be the technicians that go out and collect the data using predictive maintenance tools. Some of that is going to be based on the operators, finding defects as they do their rounds and review their processes. So the percentages that I've showed you in that maintenance model, maintenance strategy for reliability, I think those are appropriate percentages. Now, how do I say this? Those are nominal figures depending on your definition for preventive, predictive, proactive, and reactive. And I've got some definitions that I use that reflects, those measures. Just let me give you an example. If you're doing a vibration, data collection once a month, is that a predictive task, condition-based task, or is that a PM, a time-based task? Well, I think it's a time-based task. You're doing an inspection with some fancy technology that tells you whether or not a defect is present or absent. Now, if you find a problem and you enter a work order because of that defect you found, then that work I call condition-based. So it kind of depends on the definitions that you use, and notionally something, pretty high percentage of your work ought to be based on the actual condition of the assets. And you ought to be monitoring something in the range of 70, 80, even 90% of the equipment using some sort of technique. It doesn't have to be predictive maintenance tools. In fact, most of it ought to be operators doing look, listen, feel, smell, process condition. And I count that as part of the condition monitoring program as well. So I don't know if I've answered the question, but that, that's my response to it.
All right, thanks, Ron. Let's see, we have several more coming in. If reliability is assured by operations team, do we have to assign maintenance workers to operators? And how do we coordinate that between the maintenance and operation teams per preventative and proactive maintenance?
Well, that was a little more complex as well. Let me say this. If you're not particularly mature, that is, you've got a high degree of reactive maintenance, your condition monitoring is not all that hot and it's not all that good, your planning and scheduling is kind of poor, then I do not believe that you ought to have the maintenance guys reporting to the operating guys. What you'll do if you do that is you'll put the firefighters closer to the fires, but nobody's looking for the guy with the matches. So until you get some fundamental systems in place associated with work management, with planning and scheduling, with condition monitoring, I think those two functions ought to be separate, with the maintenance guys reporting to a maintenance manager and the production guys reporting to a production manager. But at that level, those two guys share some measures around maintenance and production schedule compliance and maintenance and repair costs. Now, as you mature, and as you get those systems in place, it's okay, I think, to devolve the maintenance guys and to put them into production areas. So it really depends on your level of maturity, and if you're not mature, don't smash them together. As you get more and more maturity, I think it's okay to integrate those. By the same token, though, I think certain functions remain central. For example, I think planning and scheduling, particularly in large operations, should be centralized with the planner allocated or assigned to an area. I think condition monitoring ought to be centralized in a central support function. I think things like pump repairs and that sort of thing should be centralized. I think contractor management ought to be centralized. So it depends on the maturity of the organization, and there's some things that I would not centralize. So that's my short answer.
Great, thank you, Ron. All right, everyone, so it looks like we're about to hit that hour mark, and so I'd like to wrap things up. I'd like to, again, thank you, Ron, for an excellent webinar, and thank you for everyone who attended, especially those who attended both webinars. And I just wanted to add, again, the final reminder that this will be recorded and on the SMRP website under Education and Webinars within 24 business hours. For those who didn't get those questions answered, I will be sending those to Ron, and Ron, you will have those emails as well, and you'll be able to send them out. If anyone needs Ron's email, I will be sending that out as well if you need it.
Yeah. Yeah, the last slide gives you contact details, and I'm happy to talk to any of you. So thank you guys for coming. Appreciate you being here. Hope you found it useful.
Great. Thank you, Ron. And everyone else, have a great rest of your day.